Welcome to this lecture series on reinforcement learning in the brain. Now that we have seen what synaptic plasticity in the brain looks like, I would like to ask, what learning rules should we expect from reinforcement learning? So we have the brain, and we want now to compare with algorithms that we derive from reinforcement learning. Can the brain implement policy gradient? Can the brain implement an actor-critic structure? And the precise questions I would like to ask now is, does policy gradient yield a learning rule with a presynaptic factor and a postsynaptic factor? Suppose we have this kind of situation. We have the state represented by radial basis functions. So the state, if I'm here, then this neuron here goes on a little bit, and this other neuron goes on a little bit more. So it's a distributed representation of the input. Then I have different actions in the output, action going north, going west, going south, going east. And we use one hot coding, which means going north, then only A1 is active, all the others are zero. Going east, only going east is active, A4 is active, all the others are zero. And the action choice is done by softmax. And then we go. What does that mean? Let's try to calculate a policy gradient rule. More precisely, let's calculate the actor-critic update rule. So we have a value output and we have the actions output that I discussed. And the inputs are represented by these different y values. And let's do this. Let's do this little calculation. What we find is the following. The weight update for connections from a presynaptic neuron J to a postsynaptic neuron I, this weight update has two factors here. One is a presynaptic factor. It depends on the activity of the presynaptic neuron. Then it has a postsynaptic factor. It depends on the actual output, one hot coding, minus the expected activity of that unit, expected given this specific input X. So we have pre and post, both are needed, but then we find that in addition there's a third factor, and I would like to call this third factor success. This third factor does not have any index. It's a broadcast signal, and I say it indicates success. Success in the sense of reward or reward minus expected reward. So let's look at this again. We have a local factor, pre, that's the xj. We have a local factor, post, that's this factor here. They are local factors because they have indices, so they are neuron specific, and this combination of I and J is specific for a synapse. And then there's an additional factor which I call success, and this success signal could be the reward or it could be the TD error.